Hi, this is Dale back for Chapter 9 demo videos. And in this chapter, it's the introduction to estimation. And if you remember back to early in the semester, we talked about the idea of statistical inference just briefly. It's the idea or the process by which we acquire information and draw conclusions about populations from samples. And there's two types of inference. In Chapter 9, we're going to be looking at estimation, and then next week in Chapter 10, we'll be looking at hypothesis testing. So we'll start with estimation, and the objective of estimation is to determine the approximate value of a population parameter on the basis of a sample statistic. In other words, we're going to use the sample mean to estimate the population mean. And there's two different types of estimators. There's a point estimator, where you're looking at a single point, or an interval estimator. And the idea is with an interval estimator, which is where we're really going to spend our time, is that we can say with some percent certainty, say it's 95% or 90%, that the population parameter mean, for instance, of interest is between some lower and upper bounds. And we're going to refer to those as the lower confidence level and the upper confidence level, LCL and UCL. So that's kind of where we start out, and I'm going to try and do 4 problems here, and hopefully I'll be able to get to all of them. Not in this video, it'll take a couple videos at least, maybe 4. And we'll start with problem 9.2 in just 1 second. So we're going to start here in problem 9.2, so I'll click over to that tab. And you can see I've already included a lot of information on this tab, and this file will be uploaded to D2L for you to look at. But p hat is the estimator there that we're going to use, standard of error estimate for the proportion, and we're going to use that calculation and then use that to estimate the whole population using a z-score, and then we've got this alpha. So we're looking at confidence intervals with this. So the idea in this case is that in problem 9.2, the proportion of successes in a random sample of 400 was calculated as 50%. And it says estimate the population proportion with 95% confidence. So I copied this table 9.1 out of page 139 of your textbook. And as you can see here, the 1 minus the alpha is considered the confidence level. So in this case, it was asking for 95% confidence. So that's right there. So the alpha is 0.5. And in this case, we're going to do both the upper limit and the lower limit, the lower confidence level, LCL, and the upper confidence. So here's where we get the formula. We divide the alpha in half, so it's this 0.025, and the z-score for 0.025 is 1.96. So we know in this case that p hat is 0.1 or 0.5. because we were given that. And we know that for 95% confidence, and I'll just put that, 95% confidence, we know that it's 1.96 because we have it right here. Now you also could go well, we'll talk about that later. We'll just use this chart for right now. So then the idea is we need the p hat, which is the 0.5, and then we need 1 minus p hat. So I'm just going to go equal to 1 minus and put p hat there, which in this case it's still going to be 0.5. And we know that the random sample was 400 again because we were given that. So now we come over here and I've got not the p hat proportion but the rest of this equation, and without the plus or minus. So I need to do this calculation. So it's going to be equal to D13, which is the 1.96, and then I'm going to multiply that by, and then I'm going to put parentheses, the square root, and then inside there it's going to be p hat times 1 minus p hat, oh wait, I've already got the 1 minus in there, so I could just go right here, B14, and then divided by the n, which is the 400, and close the parenthesis. And I've got an error in my formula. Didn't like something, but it worked out okay. The 0.049 would be correct for that. And then down here, I just wrote in the formula so you could see it. It's basically the p hat plus the z-score for the confidence interval. So in this case, it's the upper confidence level, which would be equal to p hat plus this C17. And in the other case, it would be the lower, which would be p hat minus what we have here. And I could put it the upper confidence level and the lower confidence level. So you can sort of see that how that's set up. Now I also took the liberty to go do the other parts, and I've sort of got them set up just to roll in. And again, you'll have this file up here. But in part B it says to redo the same thing, but with the p hat proportion at 0.33. So put a 0.33 in here, and now it automatically calculates the rest of that. And again, you can see the difference there. So instead of upper confidence level of 0.549, it's 0.3761. In the case of the lower confidence level, it's 0.2839 rather than the 0.451 up here. And there was one more example in part C, which is instead of 0.5 or 0.33, it's 0.10 or 10%. And again, scroll down, and I had just copied these other things in here, and I forgot to update this. So instead, this should be 33 times 0461, and it should be 33 0.0461, and down here should be 1 times or plus 0.294, and it should be 1.0294. So again, you see that the upper confidence level changes as well. So that gives you a basic idea how you, when you change that proportion. And again, if you wanted to go back into table 3 and look these up, that would be the other option rather than using the 4 common ones. But typically these are used so frequently that you usually don't have to go look them up in the table. But we'll take a look at that in a minute. Let me just pause for a second and then I'll come back and show you the table 3 examples. So I'm back. Like I said, typically most of the confidence levels are found within these 4 tables. But if you did, for instance, want to look at it in the table here, table 3, it gives you the score. Again, the picture up here is helpful. So in the case of 95% confidence, 1 minus 95 is the 0.05, and you divide that in half and you get 0.025. So 0.25 from 100 actually is this, 0.975, and if you go over here you get to 19, and then you go up here to 0.06, which is where you get that 1.96 for the confidence interval. Again, I pretty much recommend that you use this, but you can get to the same number using the table. Alright, I'm done with this video and we'll come back and look at 9.4.